once more to this frequency variator course or drives. It's about time to getting close to our practical part. However, the person who's going to be connecting and such is basically going to be watching while I explain to you step by step how to run your configurations for your different drives. However, I'd also like to talk about something that is very important, something that I would like that it was a little bit more common in our drives course. And also that it's an important topic at the moment when we are running our practices, our drills for the first time in our company. Or something that, in your workplace they explain to you in detail. You've probably already heard about emergency stops, right? And they're very important, but there's sometimes that they force us into taking some security courses. But what happens in our drives work? Sadly, at least for me, it's sad that there's not really the right time or place to talk about this. And that's why I wanted to take this opportunity and talk about it with you guys. So more than the goal that it is to have an emergency stop, many of us think that this is to save the electronic equipment, which in this case is the drive, because this is an expensive device. And if the motor burns out or the equipment, more than that is protection to ourselves and the people who are around the machine in charge of using that motor or that drive. So if we as engineers are in charge of automation and we are in charge of configuring, and in such a way we're also in charge of electrical installations, we can cause an accident for someone else. That's the main reason for security issues. To protect others, protect ourselves. So therefore, here is where we get our emergency stop part. I had previously told you that before our drives, we also had our contactors. Okay, contactors, our relays, our overcharge relays. Now, how was motion in our motor interrupted? So we activate our emergency stop when we notice some sort of danger. Okay? So since this is an emergency, how did we do to stop unexpectedly our motor if we didn't have any other drive? Well, simply, we had to interrupt a line or two lines. Okay? Because this emergency stop, if we flipped it over or if we turned it around, we would be able to see that there are different spaces for us to add our different blocks or our contacts, which in this case are normally closed. Now, remember that all the brake part and the tension part for any device needs to be regularly closed. In this case, it's not it in this case for emergency stops. Now, there are some drives which are stopped when a phase is interrupted. However, if we want to ensure that the drive shuts down, then we should interrupt two phases. That way we can stop the drive or we can shut it off, and if we shut off our drive, then in that case, the motor is going to stop completely. Okay? Because we're not sending out any other voltage to our motor. So this is with our drive. With our contactor is exactly the same thing. We have to interrupt our coil for our contactor. Okay, so previously there was an interruption in the lines for our motors. So that was a long time ago. And then when we got about our coils in our contactor for the big ones, we had to interrupt one of those terminals. Same thing as we see here on this side. So all we're doing here is setting up in series our emergency stop, but this is still in our same circuit. It's not the best way to do it, but it is our way to do it. Okay? This is a method to get our contactor to avoid that it's energized. So we have to add our emergency stop before our feed in number 1. Did you guys notice this? By interrupting this circuit, when we want to start up, it's not going to be possible because it needs to go by force through here. So we had to add our voltage to A1 so that the contactor is closed, the coil is closed, the cycle is closed, and it may allow the flow, the energy flow for A1, A2, or A3, which in this case is our motor load. That was another way to do it. And I've seen other ways that people do this. And that's okay. But if we have a drive, the way to do this correctly is not to interrupt the line or an emergency stop before the stop. That is incorrect, actually, and this is why I'm telling you this. Now, what's the right way to do this then? All right. This, we have to do it through our diagram, through our drive diagram. Now, this happens in all of the drives, okay? So we, as I previously said, we cannot add a button before our stop button, okay? This is for our 3-wire. Let's see here, so it's 3 wires. Let's look right here. So if this is my stop button, sorry, my stop motor, I couldn't have added my emergency stop. So this is incorrect. Please do not do this. Now you may ask, well then in that case, what do I do? Or what should I do? So if you already have here your connection, whether it's 2-wire or 3-wire, leave it as such. So you need to add a different connection in a different terminal for digital inputs. So this is one way to do it. And also you need to add your stop in this input as regularly or normally open. Now we should look also for our digital input, our immediate stop or the quick stop. Okay? We should do this by activating this signal, which in this case it's asking us for a normally open. But remember that it should be normally closed for security reasons. Even though they tell me, well, here in the manual it's telling me that it should be normally open. Please listen to me, guys. It needs to be normally closed. Why is this, you ask? As I explained in different courses, but I'm going to explain it to you again. If my block fails or my regularly open contact fails at the moment when there's an emergency and it's set as normally open, and I press this but it doesn't work, it's never going to close. So if it's a real emergency on the field, if I press this, it's not going to activate it. It's not going to send out my signal to my digital input. So therefore, my motor is not going to stop, and there's going to be a huge accident. Which is something that if the block fails, before something really happens, before we need this in reality, it's going to open up. And if it doesn't get the signal, it's going to stop absolutely everything. So I'm not really interested that everything stops. So what I want is that my device works. Okay? So let's suppose that we're in our regular workday, and for whatever reason the contact fails and it opens up. So it's going to stop this. And at least it's going to give us enough time to analyze what happened. And if this stop button is active without me allowing it, then in that case I'm going to go to my maintenance team. Okay, I'm going to go to them and check my tools, my inventory, and I'm going to change that block to whichever one that works. But in the meantime, my machine is telling me that there's a problem, which is something that does not happen with my regularly open cycle. Okay, it's not even going to tell me that that block failed. And whenever there's a real problem, that's where we're going to have more problems. Okay, so that's our difference there. Always keep it regularly closed. And we need to choose our option for Yaskawa. There's some other things that are already assigned to these parameters and digital inputs, where it says this is the emergency stop. However, it is telling me that it is a quick stop. And if it's a quick stop, it means that there's an emergency stop. So also something else, another way to get an emergency stop. Now this is that I am telling you is okay. This does not have any problems at all. So what I had previously told you about your digital input as tree wire or that you added before, that is incorrect. If we interrupt our drive feed, is incorrect. It should not do this. Why, you ask? Because we light up and power on, off, and power on and power off. So you need to be very careful with this, guys. But if it's only with a controller, then it is very safe, and we also stabilize our useful life. Okay? Now, what else? The other way is if we analyze our diagram, we have our safety switch, which is HC H1. And here we have a bypass by default. So here it's telling me to add my safety switch. Okay. Now, why would you think that this is bypassed? If there is no signal between H1 and HC, everything is going to stop. It's not going to allow me to start it up. It's actually going to send out a failure notice informing that something is happening with those inputs. So by disconnecting that bypass and adding our emergency stop buttons. So here what we can do is we can add the emergency stops, whichever ones we need. But we should never leave them in parallel. It always needs to be in series. It may sound a little bit too obvious for you guys, but it's something very important for you guys. Okay, so you guys won't say, well, should I only use one emergency stop? No, that's the beauty of this. You can use how many you wish. Okay, just as long as you know that it always needs to be in series. If it's paralleled, that emergency stop is never going to work. So you need to be very careful. Now, finally, we head out to our simulator. And we're going to run out to our emergency stop. Now, we have here connected our emergency stop, and this is where we add our base block hardware. For example, for motion, and we know this as hardware over travel, which is a security device that our servo drive has. And here our drive has the same thing. Now, this device is always bypassed. So if we wish to remove and remove this emergency stop as regularly closed. Okay? So we have to start this up. Now, what would happen if I remove or if I activate my emergency stop? It's going to stop clean, and it's going to send out for your alarm. So it's going to tell me, we already activated your emergency stop or your emergency switch. If it's active, then it's going to say, well, it's under command here. It's going to get more mobility. I'm going to be able to start it up. I'm going to be able to switch it around. And if it's not present, I'm basically not going to be able to do a thing here. Okay? So I'm not going to be able to do a thing here unless, even if I try to reset the alarm, unless I activate this once again. Okay? So here we have nothing and nothing and nothing. Reset, nothing again. Okay? Again, as I said, I'm not going to be able to activate a thing unless it's being activated. I was unable to, that's why I couldn't do it, because I wasn't able to detect anything. That's how we stop clean something. Okay, so this is a quick stop. Now, if we analyze, we're going to be able to see that in theory, it should indicate an emergency stop. So it doesn't show up here. Okay. So we go to the English version. That's emergency stop. Now, this is the difference that I was telling you about in our previous video. The importance in using a Spanish language manual and an English language manual. Okay, because they have different jargon. Okay. For example, if we look for emergency stop, we get fast stop. Okay, which is what I had previously told you. So fast stop is 245. This is, as it says, fast stop or quick stop. This complies to the C109 instruction. And it says the quick stop listens to the quick drive. So now this is where most people get confused. And they say, well, you're telling me about one of the options is through external digital inputs. So this is, I can configure whichever one I wish. If I want to choose C3 as emergency stop, that's where I'm going to connect it to. And if I connect it to S5, then I can also connect it here on that part. So you're telling me right now that my manual is telling me and indicating me that I can use this as an emergency stop input or for my button. So then in this case, it's correct. But then at the same time, you're also telling me that I can use this as an emergency switch. And if I add here my emergency stop, it's going to work, which it is what's going to work, but for the motor. So then what is this all about? I can even tell you guys that both ways are correct, okay? Both ways are absolutely correct. So you need to choose the one that is more feasible for you guys. If you don't want to configure your input and all you want to do is the other part, just remove the bypass and add it again. So this is the hardware part that I like the most, because in this case we can basically we are obligated by the system to add this. So this is a system issue. We don't have to set anything up. But if we want everything to be established and standardized with our diagrams and say that whichever or this input is emergency input or something, that's also valid. But it is essential that you guys know about this and you guys know the reason why we analyze how we learn. So that's why I wanted to show you guys. So this is very important, guys. Okay? Now, you need to pay attention and you need to say what is really better for you guys. So any comments, please leave it in the bottom part. Send me a message. And if this part is not clear or not clear enough for you, please send me a message. It is very important that this is good for you guys, that this is clear to you guys. If something is not clear, send me a message. I can explain it to you in detail. Safety and security is the most essential part in the automation process. Because whenever a motor wants to tear a finger off, it's not going to ask the person. Simply put, the motor is going to start and it's not going to care. So that's why this is very important, this security thing. That's why I would rather repeat this 1 or 5 or 10 times. I don't want any accidents. And you should neither. So that's why we need to practice this safety part. Okay? So having said this, it is now moment to move on to our practical part. Okay? So I'll see you guys in our next videos. Thank you very much for your time. And please, we'll see you guys in our next video. Big hug.